How's it going? I am Ali. This is part 2 of our workshop where we talked and worked with Dockers. This one is more aimed towards being practical as compared to yesterday's, which was aimed to just be more theoretical and maybe some practice stuff. Yeah. If you want to follow along, I've posted a link in the group chat for the workshop where you can just where you can just click on the Play with Dockers and just follow along and see how it goes. Feel free to stop me anytime for questions. I might miss them out though, so sorry about that. But I'll still try my best to answer them as I go through. This workshop is going to be, we're going to be focusing on a lot of cool stuff, but a lot of cool stuff for Dockers. Due to some technical issues with the Docker Playground, I don't think I'll be covering Docker Compose, but instead of that, I'm going to be going over how to set up a continuous integration pipeline with Dockers and why it starts becoming sort of useful at this point. So, are there any questions or shall we go ahead? All right, so first thing you got to do is you got to go to the Docker Hub link, labs.playwithdocker.com, and copy link. I'm going to open it in incognito so that you guys can follow along. Play with Docker. I'm just going to put this back here. And generally it asks you to sign in, but I just signed in like 2 minutes ago, so it's going to ask me to go for it. Then I hit start, and let me just close this one. Yes. And it's creating a session for me, and it seems like it's done. Fantastic. So I now say add new instance. A new instance essentially means a new virtual machine that's going to be hosting Dockers. It takes a moment and everything is online. Fantastic. So is everyone following along to this step here? If it's silent, I'm going to assume that to be true. So I'm rearranging the my windows. Give me a second. Right. So first thing we got to do is simply install a text editor. I'm going to be just using Nano because it's just simple for a lot of people to work with and follow along. This isn't necessarily running. I forgot which version of Linux this is running, but I think I want to say it's Alpine. I'm like 90% sure it's Alpine. And what I'm planning on doing with this is essentially just, well, firstly I'm going to install Nano, and that's simply done with the apk add nano. This command is, then we can use Nano to install anything we want. VI, Emacs, they're also not installed. This is a very minimal thing. Literally nothing is installed on this. So to sort of get it working and stuff, it's a very minimal playground. So apk add nano, it's fetching, and it's installed it. So now we can do nano abcd, and boom, we have Nano. To exit out of Nano, you can just do Control X, and it'll take you out. If you have some modified stuff, it'll ask you, and then you can just press yes or no, and it's fairly straightforward. If you want the instructions, they're usually written down here. So you can do, if I were to do Nano, and I were to type some stuff in, and I press exit, it says save modified buffer. Yes, no, and I hit no, and it just ignores it and exits anyway. Right, so that's fairly straightforward. I hope you guys are following along. So first thing we got to do is create our work directory as well as the app itself. I generally like to create a work directory by, let me just paste the command in the chat just so it's easier for you guys to follow along. apk add nano. So now we make the work directory workspace, and that's done with make mkdir, and then we just do workspace, and then cd, and then we can just do mkdir workspace, and then we can do app. So this is typically how your GitHub repositories are going to look like. You have your GitHub repository name. I just call it workspace if I don't really have something off the top of my head. cd workspace. And now we can see that app.py app is inside it. So app is generally where we keep our app files, and we define our Docker Compose, and sometimes app.py is stored over here as well. But I'll be putting it inside the other directory just to sort of keep things a little bit more organized and to keep things abstracted. So first thing for this Docker workshop is we're going to try actually pulling and running a Docker, I want to say image? No, a Docker container, sorry. Words just not happening to me today. So that's a very fairly simple command. It's just docker run hello-world. What this does is that on Docker Hub, we hello world. Docker Hub is like sort of like GitHub. It's essentially a repository. It's essentially a website that hosts repositories for all of your. That's weird. Hello world. I think this is the most popular, or one of the top popular ones. Yeah, over 1 billion downloads. What it essentially does is it'll go to this website, it'll pull the Docker image that we need, and then it'll immediately execute it. It's pulling it only the first time because we might not have it on our system. To sort of compensate for that, it just pulls it the first time. So Docker run hello world, unable to find image locally, latest pull, and then it does the pull. It's downloaded status, downloaded newer image for hello world latest. And then we hit run. And now we just wait. Generally doesn't take this long. Just Control C out of that. This is awkward. The awkward moment when your computer gets hacked and it's just not working. Error response from daemon. That's weird. Let me try that again. Docker run hello world. This is fairly weird. Docker run hello world. Unable to find hello world status. That should not be this. I have no idea why this is happening. All right. So small plans, small change of plans. Instead of doing this in the Docker Playground, I'm going to be doing on one of my servers that I have working instead, because it seems that the website is acting weird. I don't know. SHB2 the great at 192.168.1.11. And I'm connected, and I'm also going to increase the font size. So properties, font 20. So let me know in the chat if it's working or not working for anyone else. I'm really sorry about that. This is completely unexpected because generally when you do Docker run hello world, it generally works. Let me try some other image that I was planning on showing. Yeah. So this is the Mongodb image that I was going to introduce, which essentially just runs MongoDB, which is a pretty nice piece of software. Yeah, it's just not working today, which is weird because like literally at the start of this workshop, like 2 hours ago, I was practicing going over most of the stuff, and it just wasn't working. So I'm connecting my server, and what I'm doing right now is I'm just ls workshop cd workshop. So I'm just creating like a directory for myself. This is running on Ubuntu now, so it should be like 90% be the exact same stuff. I'm like pretty confident about that. May have to change some ports because it's already running an instance of MongoDB, but it's fine. So make directory workspace, make directory workspace / app. Oh, sorry, not workspace / remove that, and instead we want app. cd app. Oh wait, no, ls. Yeah, that's weird. Okay, we have app. So, all right. So now that we have workspace, I'm going to run Docker run hello world again, and this time it's actually going to work. This is actually what's supposed to happen. It pulls the image from Docker Hub. It says, hello from Docker. This message shows you your installation appears to be working correctly, generates this error message, and works pretty nicely. Yay. So now, like, that's a pretty cool thing, I guess. Just shows you how it works. Oh, let me just paste this into the Discord as well. Can everybody see okay? Shadowlearn, yeah. Well, let me know if there are any issues or whatever. Okay, so workshop workspace. Thanks. So now what we're doing is essentially running a MongoDB. So just can someone type out like how familiar you guys are with MongoDB and what it is? Because I don't want to like give you guys a long-winded explanation. Okay, Shadow knows nothing about it. What about Rainbow or Henry or Yikes? Okay, 0 and 100. Wow. Technically that's the same score, but for some reason it just looks so much more. All right, I'm getting the general consensus that nobody has any idea what MongoDB is. So congrats, you're going to learn something new today. So MongoDB Compass, and all right. So let's go with 7 gets hosted to 6. I think this should work. I think that's the right syntax. So this is MongoDB Compass. It's built by the guys who made MongoDB, obviously, and it lets us explore and work with MongoDB databases, or better explained as NoSQL database. What is a NoSQL database? It's, to put it very roughly, a database that stores all information as a JSON format. That is not an accurate way to define it, but it's a quick way to define it. Does that make sense? Are you guys familiar with what a JSON file is? Shadow, Yikes, Rainbow, you're my people here. Okay, Shadow knows about it. Yikes, no. Rainbow, you're the tiebreaker. No. All right, so what is a JSON file? A JSON file, very simply put, is, okay, you don't have to be smoke, Shadow. Huh. So, JSON, let me know if this is like too small. Yeah, I think this should be fine. So a JSON file is a very simple file, is essentially a very simple file structure. So let's say the people attending this workshop right now. What I need to do over here is say, I have 5 participants. Wow, that's kind of sad. Huh. So a JSON file is a very easy to define function. One second. I'm looking for the actual definition, so I want to make sure that it looks like I actually know what I'm doing. So a JSON file or a JavaScript object notation is a minimal readable format for structuring data. It is used primarily to transmit data between a server and a web application as an alternative to XML. So as you guys probably know what an XML file is, it's one of those ugly stuff that nobody wants to work with. I won't explain that because we have a finite amount of time today. And I'll just briefly go over what a JSON file is. So whenever you have two machines that are talking to each other, you generally need a way to transfer data that's so flexible that it can transfer data, that it can transfer any type of data without any problems at all. How do you do that? Well, you hope and pray first. But more importantly, what you do is you usually send messages through a JSON file. What a JSON file is essentially, actually, if I write one out, it actually might be easier for you. So name, workshop. I can't spell either, wow. Event underscore name, workshop, event name, participants. I definitely messed up the spelling of that. It's not great. Now I'm insecure about it. I gotta look up what the right spelling is. Oh yeah, wow, I actually got it right. Surprising. All right, so participants, I have 5 people, so I'm just gonna add them. Like, okay, so interestingly, to those of you who might be familiar with Python, you'll notice that this looks sort of like a dictionary, Python dictionary, where you essentially have where you essentially have these curly braces and then you have a string or like whatever value colon the other value, and then participants colon a list, and then this can have like another dictionary inside it for name, and then say yikes, because he's the last guy I messaged. And then you can add some other information such as age, who I'm going to assume you're like 17, but actually I have no idea. Okay, and this way it's sort of like, so this way you can actually pass any type of information here as long as it's a string or number or float. You can actually pass quite a lot of different values over here, right? So, sorry, once you get into the habit of formatting stuff to make it look nice, it's just obsessive and you can't stop, like an addiction. So over here you can sort of like define any type of information you want. And the second person I want to add here is Shadow. I'm too lazy to write your full name, so I'm just going to call you Shadow. So this is essentially a JSON file. What this lets us do is sort of like, let's say I was looking in Python for information about all of the participants. And I have a variable called, let's call this a equal to this. And then what in Python, for example, what I do is I want to get information on all the participants, a of participant, so print a of participants, and can anyone tell me what this is going to return in the chat? Shadow, come on, you know this stuff. Okay. Oh wait, someone's typing. All right, fantastic. I'm a terrible teacher. So is it because you're not familiar with Python? Because in that case, I'll just make it even simpler. Essentially, a JSON file is just used to store information, and it's used to store a lot of information, depending on the use cases. I've personally seen this handle everything from databases to weather information. Yeah, the Python thing. Yeah, weather information to whatever. To high-level scientific information. It's not a perfect format, but for some cases where like you don't know, for example, if nobody comes to the workshop, then directly from this. Yeah. So the benefit of JSON is that it's super flexible. So like I could literally just not have a single person edit, still work fine. I could literally not have the participants' information, and it would still work fine for a machine to be able to iterate and do stuff with it. So does that make it a little bit clearer, Rainbow and Yikes, about what a JSON file is? Yep, that's pretty much a JSON file. Like if I save this right now and store it as a downloads. Yeah, my computer's. So yeah, this is a JSON file. It's a very convenient file structure. No, it's like a CSV. Are you guys familiar with the CSV is? Comma separated values. I mean, it's one of the most basic file formats. Nope. Okay. CSV, comma separated values. You know how in Excel you have like all of these values that are separated by rows? Well, some smart guy said, hey, Excel is pretty bloated. It lets, instead of that, just store values one after another. So for example, again, taking the event stuff, we have event, comma, time, comma, average age. All right. So over here, we define it as workshop, the time as 7:30, and the age as 17. So generally, what a CSV comma separated value is that it stores information in the form of it's just using to store information. It's no different from a text file in which you can store information in, right? Does that help explain how it's different from a like piece of code. It's just storing information, and this is information as well. So if I had like participants over here, like there is no easy way for like because I can like repeat this 100 times, and it still makes sense, right? Right? But over here, the benefits of this is that what if I have a like a list of people who I want to add? In that case, I would probably like have to add another row and sort of like have participants party because I'm lazy to type. And I have yikes, and I'm like, shizzle. I now have to also include rainbow, and then there's this information that's being repeated, and that's not really nice. So generally what a database does is that it tries to optimize these sort of things. SQL database, for example, will try to create some clever stuff, which I don't want to get too much into, but it is super cool to just reduce that amount of headache that it has. But a JSON file is super flexible in the sense that it can store literally, like we can have multiple participants over here, no problem, and we won't even notice a difference. So what a MongoDB Compass, what MongoDB does is that it automatically, one second. So this is just one of the databases that I have set up on one of my servers. It's for my capstone project, which works on facial detection and weather data. So let's open one of the weather data files and let's view it as this format, right? So date time, data, and yeah. Can you guys see it? Is there some way I can zoom? Yep, okay. I'm going to assume you guys can see it then, because you literally said yes. So what you're seeing this right now is very similar to this format over here, right? So you have date time, it's in quotes, it's similar to how it was done. A lot of it is also like folded up, so it's easier to work with. And like I have all of these like documents that contain information on like the weather data that I've been collecting for the past few weeks. This is just for a project where it just collects weather data, and then I have a phone app that's stuck to my wall that just tells me what the weather is. I know, I need a life. Huh. So essentially, this is just a simple JSON format that's just storing literally everything inside it and works beautifully. Because this way I don't need to like plan out things beforehand with how I want to access the data or work with it. I literally throw whatever information gets returned over here, and I'm like, hey, it works, it works. So that is essentially how a MongoDB stores information. Does that make sense to you guys? You can say no if you just tell me what you're sort of unfamiliar with. I'm going to assume you guys are still sort of like struggling just because until someone contradicts me. So the way a MongoDB database is set up is that you first have the database first you have the databases inside it, which sort of contain information on exactly what, which just have, you can have multiple databases inside your database server. It's kind of weird, but essentially, I'm just going to gloss over that. Why not? Then inside a database, you generally have collections. This is pretty similar to having multiple JSON files. And yeah, it's just that. It's literally like having multiple JSON files that contain different information in them. Then, for example, inside each of the collection, you have documents. And each document has information pertaining to whatever is supposed to be there. And that's where most of the stuff is inside it. And that's, for example, where you have all of this data, which is very similar to a JSON format. Does that make sense for you guys? I'm literally going to wait for you until someone either says yes or no. Yikes, shadow, rainbow. Kind of, okay. All right, so yikes, just so that I'm like sort of know, what is it that you're not 100% on? Can you just like tell me that? Or like, is it just because you haven't seen it be used enough that you can like talk, like be like, okay, cool. very useful, very flexible, very powerful, and it's very. It's I think people definitely use JSON files for almost everything, and it's just pretty useful. Honestly, if you want to learn about it more, work on a project. So I have my local instance running over here, and what I want to do is I want to run a MongoDB instance. So first, let me just check if I actually have something that's running MongoDB. Yeah, that's what I thought. 7, so 6. So just sort of explain what's going on over here. Docker run will essentially be the same as the hello world that we just ran a minute ago. And what it's going to do is it's going to name our container as MongoDB _DB. I'm going to rename this as container actually, just to make it a little bit easier to follow. And then I say detach it so it doesn't like show some information on my screen like all the time and just detaches and quits. After that, I do -p, which is expose the port so that I can actually connect to it and do stuff to it. And then finally, I'm going to be saying, like, so the first one over here is which port needs to be exposed to the entire world, or like map. And then the second one is what port is it inside. So what port is inside, what port is outside, and it can sort of be different. I could literally have this one be 25, for example. Pretty sure that's bad practice, but it's whatever I want. 7016. And then Mongo is just the name of the Docker image. So when I hit run, it creates the image. Generally, it would also pull it as well. That takes about I'd say a couple of seconds. I have decent internet, so I'd say a couple of seconds. And then we go to Docker Compass, connect to. I think I can close the other one. Like 1 second. So yeah, I hope you're sort of like following along with what I'm talking about. Let me know as usual if you have any questions. Oh yeah, let me also post the code snippet in the chat. All right. For reasons, I'm just gonna keep it to 7 on the code because that's just what it's supposed to be. MongoDB Compass.connect, and I do MongoDB : / and 192. Yes, I'm that lazy. Do 7016, and I think that should be it. Connect. Oh, hey, look, we're in. So MongoDB Compass essentially lets us explore and work with our database without in a very nice UI. We can create our own database and view performance metrics and stuff like that quite easily. As a matter of fact, I'm going to the performance stuff here. Oh, well, whatever. So works pretty nicely and looks pretty nice, but we're going to focus on the command line because it's just a little bit easier. Also, in case you guys want to I'll just post the URL as well on my local machine. You can change around with it however you see fit. You guys probably don't have MongoDB Compass installed. That's perfectly fine. Docker is supposed to be the last thing you'll ever install. And here's how you would do it without actually installing the toolset. Just do Control V on mine, sorry. So Docker execute IT in the terminal in MongoDB. 1 second. Container. What this essentially does is that it lets us connect to the MongoDB instance and start using its terminal, and where we can actually start doing some interesting stuff. So let me just post this command onto the group. And I know for you guys, it's supposed to be your command is going to be a little bit different from mine because I'm just gonna because in my instance I already have a MongoDB text running, but MongoDB server running. I'm calling it something else. For you guys, I'm just going to leave it as MongoDB just because I don't assume you guys have it. Docker execute -it container image, MongoDB container, Mongo. A whole bunch of text is going to show up like it did over here. And it's sort of going to be saying about all these things, enable MongoDB's free cloud monitoring service, blah, 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 blah. And I just hit Control L on my keyboard. And the first thing I want to do is sort of see the databases that are currently on my system. So that's fairly straightforward. I can literally just do show DBS, and it just shows admin config local, which is pretty consistent with what we see over here, admin config local. So next, what we want to do is maybe like show the currently used database. By default, it is always test. But the reason it's not showing up either here or the other place is because it doesn't actually have a file in it, which sort of stops it. Yeah, it doesn't actually have any containers in it. So, oh no, not any containers, any documents. So what if I were to create my own database, say use app_db, this will create our own database that we can then do some pretty cool stuff around it. So we can just do use app_db and press enter, and it says switch to database app_db. If I now do show dbs again, it still doesn't show up. And when I do db, it still says that it's appdb. Now, I'm just going to post the command for the use appdb so that everyone following at home can do it without any problems at all. Great. So my internet is also starting to like lag a little, so Discord is acting weird. Though it's probably because I'm streaming my entire my monitor screen. So show currently use DB, we just did that. And let's say we want to create a database for movies, like my weather app, but now we want to show information for movies. So that's with a fairly, that's with a fairly simple command. First use, and then app_db. And then now all we got to do is db.movie.insert. So what this does is that it inserts, so it'll automatically create the collection movie that we saw. And because that's how flexible MongoDB is. It literally does not care if something exists or not. If it doesn't exist, it'll create it for you. So this way you can have your structures and stuff working pretty quickly, pretty fast without any problems at all. The downside to it is you are much more likely to have bugs, but as long as you develop properly and make proper plans as you start going, generally works out pretty fine for you. So db.movie.insert. So over here, I want to insert movie information about the movie 7 or Frozen. Let's go with Frozen. That's less mature. So more age appropriate. Yeah. Name, Frozen, and you put in the quotes. You'll notice that this structure is exactly the same as a JSON file, and JSON files are used literally everywhere on the internet. Like, the internet is literally built with JSON files. So you cannot go anywhere. You can, like, Discord is probably using JSON file right now. So db.movie.insert, you do name Frozen, and I hit enter. And now when I do show DBs, it's going to show, hey, our app_db exists. And we can actually look into, our app database exists. And over here, we've defined collections as, like, it shows that there's one collection and there's one index inside it. I don't know why it's taking so long. It's generally pretty fast. Like I said, my internet is just super slow today. MongoDB Compass, and now we see movie, and now we see our wonderful movie Frozen. And yeah, so this way we can also add like more information to it. So let's say instead of Frozen, we want to do Narnia, because that's a really old thing that I really miss and off the top of my head. And we want to say that when did Narnia come out? December 7th, 2002. So release date, December 7th, 2005. And we do it, and it works again. And now we can go back over here, refresh, and wunderbar, it's here. So this way we can sort of add and write stuff to the database itself. It's pretty useful. And if we want to like find out some information, we can do db.movie.find. You can hit tab on your computer, and it'll automatically fill in the information on it. And for MongoDB, it's fairly straightforward how you find stuff. It's just like you start giving it parameters that you want it to search for. So let's say I want to do find one. It'll find the first one, and if I just leave empty, name : Narnia. And over here, I have all the information. It defines an ID to it by default. Name : Narnia. Release date December 2007. This is super useful when you start actually working with data with a backend and a front end working together. So I just exit out of there by pressing Control D. Let me just paste the commands. All right. This is a bunch of commands because I just glossed over a bunch of things. All right, I just sent it. Yeah. So show databases, show DBS, create database, show DBS, currently used database, and 7. Right. So now, that sounds super fun, right? Right? But now what we're going to try doing is actually making something useful out of this. So what we do now is very simply, we start actually creating our own Docker image and building our own Docker app. So what we do now is we do cd app, so it goes to the app directory, and then do nano app.py. This will create the new app.py file, and then we can enter some cool stuff in it. So what we're going to be trying to do over here is create our own fantastic Flask application that, so I assume none of you are going to be familiar with Flask, are you? Can I get an amen in the comments or in the chat? All right. Nope. Okay, cool. So, all right, chat, you're pretty well learned. All right, so how it works with a, how it works when you come to front end and back end development. Actually, web development, I actually went over this a couple of days ago. Diagram. Let me just see if I can find a diagram just so it makes it a little bit nicer. I don't know what the actual term is. Oh, is this it? Oh yeah, cool. So how this generally works is, that is a tiny image. Can I just zoom into this like that? Sure. How generally, it's terrible. Right. So how it generally works is that, let's say you have 3 things set up. I'm a very artsy person, so I can draw it better. Let's say that you have a app, right? So you have your mobile phone, and this phone is generally connected to the internet, right? So your phone, it's connected to the internet. It does a lot of cool stuff. Facebook, Instagram, Reddit, so on and so forth. So what you see in your hand when you have that stuff is, okay, let's take an example of you and your friend are developing an app together. Your goal is to essentially get something out of, like, is that you have your phone. What that phone does is that it collects information. How do I explain this? So you have your phone and you have a computer and you have everything else in the world. What your phone does is that it goes to a website like google.com, and when it goes to Google, what it does is that it is that Google.com says, hey, there's a website over here, and if I just click on this one, it'll automatically look at it and say, I just want to go to Google. Oh yeah, it's Father's Day. Go tell your parents you love them. All right, you go to Google.com and boom, the front end shows up, and then you're like, hey, I want to search something like, no, don't show my search history. Bad Google. So let's say I want to search something like, how old is Discord? And I hit enter, and it shows up. So what's happening now is that I have this massive query over here that Google has information for. Let's not worry about that. You'll notice that there's actually some information stored. It was here like a second ago. Like how old is Docker? You'll see how old is Docker, is Discord show up over here. So what happens is your front end talks to your back end, and they're generally two separate systems. They can actually be as many systems as required. And what ends up happening is your backend then is this place where you essentially get requests and you process them, and you can either connect to a database or you can do some other stuff with it. Does that make sense to you guys? I know it was a long explanation. I don't think I said too much. Just does that help? Yikes, Rainbow. Okay. I hope that actually helped because yeah. So, no, should be in the window. So, all right. So, what we're going to do is define our Flask application. Flask, for those of you who don't know, is a very nifty tool that essentially lets us work with. Yeah, Flask is a pretty nifty tool that lets us work on a backend. Like it makes a backend so that we can actually connect to it and start doing some cool stuff with it. So I will literally just show you how it works. So this is a Python file, right? app.py. So we're going to be following the Python structure, Flask import Flask, and then app equal to Flask __ name at app.route. Don't worry. As we go through the workshop, you guys will be able to follow more and more what's going on. Yeah, let's go to tabs. Return hello world. I can't type at all today. If __ name equal to main app.run, host equal to 0.0.0.0, port equal to 6002, because why not? Control X, we save it, yes. And file name to write app.py. We can change this as well. It's just something that Nano does. And I'll post that code snippet because I'm pretty sure none of you would have had the time to actually type it out. You'll notice that on yours it's 5,000. On mine is 6,002. The reason is because I wasn't sure, because I thought the Docker thing was working at the time. So yeah. So let's say hypothetically over here where I was planning on running it, I actually didn't have Python installed. Did not. And boom, bash Python command not found. Python 3. Oh wait. Oh, Python 3 actually works now. Wow. Like it wasn't working a while back, and this is just weird. Okay, so let's say it's actually not installed over here. I type Python and nothing ends up happening, right? It's just broken. And this is going to be pretty broken almost everywhere. Like if I do Python app.py and I run it, oh wait, sorry. I forgot to put the host in quotes because it's supposed to be a string. Python app.py, it says module not found, no module named Flask. I can either do pip install Flask and it's like, oh, blah, blah, blah. It works, but let's circumvent that by just adding a requirements.txt. You'll find these in pretty much every single place. It's just nano requirements.txt. Very, very common for Python. You just do that and just literally type Flask. You can either even specify a version like I think the current one is 1.07 or something like that, but let's just leave it at Flask for now. It will work. So now we got to create the Docker file, which is actually going to host our application. And we do nano Docker file. And just, let me just add the stuff for the requirements.txt. If you guys want, I'll stop posting the code after like every second I type it, but it's just nice to have it. So in the nano requirements.txt, in the requirements.txt file, you just add Flask and it should work right out of the bat. And in the Docker file now, a Docker file is essentially a file that contains the instructions that you have that define exactly how your application is going to be built. So my advice is generally practice makes you perfect. And since I am perfect, haha, funny. So from Python 3.6, I'm using 3.6 in this case because Python 3. While 3.8 is the most stable one, I found 3.6 to be pretty reliable because some packages aren't built for 3.6 yet, right? So from Python 3.6, this is essentially going to be the image that it's going to pull from. We're going to copy the requirements file and the app directory as well. And then we're going to run pip install-r requirements.txt. Does everyone understand this? Henry, Higming, you guys haven't said anything the entire workshop? Are you guys following along? In the meantime, Rainbow, yikes. All right. Is everyone else following along? I'm just making sure of that. All right, dead silence, just the way it usually is. So now that we have that, we do Python requirements.txt copies the requirements from where this file currently exists to the requirements and stores it into the Docker instance as well. We can also just do copy ... and we don't have to like use these two then, but it's generally considered doing this as bad practice. I just want you to be aware of it. And yeah, so pip install-r requirements.txt, and then interestingly, the run command is used whenever we want to. Run command is generally for running it when you're building it, and then the cmd is to execute it when you're actually running the container itself. So say modified buffer, yes, file name to the right, Docker file. So I'm just going to share that code with you guys so you guys can work with it as well. All right, just 1 second. And enter. So nano Docker file from Python 3.6, copy requirements.txt, blah, blah, blah. So now we actually want to build the Docker image, and this is where the fun begins. I'll just post that command so you guys can follow along. And when I do docker build-t app dot. So what this does is it says, hey, Docker, build it with the tag app and use the current location as the context. So sending build context to Docker daemon, it's this file. So the first command that runs from Python 3.6. I have Python 3.6 already running, but on your system, you should see it being downloaded and installed. Python Alpine, which for the Dockers is even more lightweight, but I'm just not using it just because. Copy requirements, it copied it. Run pip install-r requirements.txt. Running in this instance, collecting Flask, downloading Docker, downloading its dangers, downloading everything, and installing everything. So it's running all the steps one by one. And then finally over here, it's just specifying that, hey, this thing is working, and that makes sense. Any questions? That sounds. Okay, so let's actually run it with Docker run. Sorry. So I'm gonna docker run -- name. So this is the name of the app container, which sort of makes it a little bit nicer to actually follow and understand. App container, it's going to be running the app image that we just built ourselves over here. Fun stuff, right? So docker run -- name app container, and then specify the ports, expose port 6002, 6002 what's internally, and put it to 6002 externally. And then we just hit run. It creates the image, and now we can just do, it creates a container, and now we can do docker container list, and this prints out all the containers that we have. So we can see this one over here started 9 seconds ago, status up 8 seconds ago. This is the port that it's exporting. The names is cut off, but it's is app container. Here's some of the other stuff that are running. Here's the Mongo one that was running a few minutes ago. You can see that its port is also specified over here. So let me just post these commands as well. And then the command that I use for this is docker container list. All right, docker container list. So now what I want to do is essentially go to 192.168.1.11 and go to port 6002. Like something should show up over here, like saying, if you guys are following along using Play with Docker, is something 5000 or 602 is going to show up over there, and all you have to do is just click on it, and it'll take you to the actual site itself. For my case, I need to go to that URL, which is, I had it like, oh yeah, here it is. So 192.168.1.11, that's the host of my server, and then port 6002. And I hit enter, and it takes me to showing hello world. Very simple, very small, works like a charm. Any questions up to this point? Because this is where the complexity starts. Actually, no, it doesn't so go high, but I just want to make sure that you guys are following along. So Shadow, Hingming, Henry, yikes, and Rainbow. Any questions? Such a wonderful class. All's good. Okay. Wait, what's our end goal? So originally our end goal was to build like a proper like backend infrastructure and just sort of like have our MongoDB talk to our app itself. But since that's sort of not going to happen because of the limitations of labs.play with Docker, I kind of don't want to like leave you guys hanging like that. So I'm just going to gloss over that part and show you other stuff. But I know, so yeah. So does that sort of answer your question of what's our end goal? It's essentially to build a backend that we can actually like query and do stuff with. And yeah, so this is like very basics. I'm just covering a lot of topics, just like the surface level stuff. So, and then you guys can sort of like learn at it on your own. This is just like the first few baby steps, you know? I'll probably give out more resources at the end of this. This is sort of like if I were to build an app, here's what my front end would look like, here's what my back end would look like, and here's how my databases would look like. I'm not that good with front end stuff, so I didn't feel comfortable with discussing it. So I just stuck with actually focusing on doing the stuff that I do know, which is back end. And even then, you can sort of like work with, we can sort of like modify this and have it return a HTML tag. So h1 hello world and h1, and I think backslash is over here. And then rerun the build. And then do container underscore 2. Oh wait, I need to bring the other one down. Docker stop app underscore container. Docker remove app underscore. Takes a second. Container. All right. And now if I were to do the Docker run again, it should automatically update this to a H1 flag. And now you can sort of see. So you can sort of use this for backend stuff as for front-end stuff, but I wouldn't really recommend it. There are a lot of better ways to do it. One of the cooler things about this is that if I were to go to app.py and add another host, say app.route /name over here, that's actually kind of important. The Angular braces, hello person, and then do name, return f hello name. So I hope all of you guys are familiar with f strings for Python. Essentially what this is going to do is return whatever name you give it over here. So let's save this and rebuild it again. Docker build. Usually it doesn't necessarily copy the thing again. You'll sort of notice that it's using cache or cache. Yeah, pretty sure it's cache, not cache. And what it does, it copies the requirements.txt. Since it notices that there are no changes to it, it just doesn't do it again. But since we're copying app, it runs everything after it. So I should probably move my pip install -r above copy app. It just makes it a little bit fast. It actually makes it much faster because then it doesn't have to do the install step each and every time, right? So let's just stop the container that we were running before, and then also remove the container as well, and then rerun it. Right. So now we already built it, so we're just going to run it now. And now I'm going to show you, if I rerun this, oh, it's still showing us the hello world stuff. I'll wait for the page to finish reloading. Right, so it shows that, but if I do someone like rainbow, because why not? It says hello rainbow. And this is sort of how you can sort of like pass parameters to it. There's a lot of cool stuff in the Flask documentation. No, I want to just see Flask. Yeah. See, instead of showing me like a proper Flask, it knows that I'm a programmer nerd, so it doesn't even bother. It just literally just takes me to the Flask page. And over here you have flask.palettesprojects.com, which sort of introduces you to exactly what is Flask and how you use it for web development. Super fun stuff. I highly recommend you guys check it out if you want to go in that direction. So docker run -name app container -p -d. So that works pretty nicely, eh? Let me just post my commands and the updates and stuff. So this is the modified file, the modified app.py file. We did all that stuff. And so generally this would be the part where I show you guys how Flask and MongoDB are supposed to communicate to each other. Let's give it a shot, actually. I think it'll work. I'm like 90% sure that it's going to work. If it doesn't, then I'm going to skip over this step because of the networking. I'm not sure if it's going to work. It definitely might not work on your end, but let's hope and pray, shall we? So now what we want to do is modify our app file to actually talk to our MongoDB database, which always is fun, right? So we do nano app/app, and we go over here. Actually, let me just do remove app and then app itself and nano app. So I'm just deleting the file and putting it in so I can just paste my code. 6002, and I'm pretty sure this doesn't need to have that. I'll change it if I need it. Paste this over here so that you guys can sort of follow as well. All right, so now I just rebuild my thing, and let me actually just change the place where this is. I'm just gonna Control-C that and delete it. So you guys will sort of see what I'm talking about. Pip install -r requirements.txt, execute. Oh wait, I also need to modify the requirements.txt file to include PyMongo. PyMongo is essentially a library that lets you work with MongoDB and connect to it and do other stuff with it. Control X, enter. So Nano, so just because I forgot to actually go over the code itself, I'll go do that now. So similar to how we were doing Flask before, we're importing PyMongo. From there, we define a client, which essentially connects to our MongoDB instance, and I'm going to change the port over here to 6 to whatever 6. We still have our endpoints defined. Endpoints is essentially like over here we defined this is one endpoint, so we couldn't go to this. Like where it's literally empty, and then if I were to put a name over there, the fact that I can put a name over there is special is another endpoint, so I can put Steven. And it says hello Steven, and yeah. So same endpoints, and then over here I define another endpoint called get movies, which when we go to this specific endpoint, oh wait, I remember this might cause a bug. So just for these purposes, I'm just going to remove this. I'm going to ignore it because it's going to be like, oh, should I pick /names or should I pick /movies? So sorry about that. Just comment it out and it should be fine. Let me actually send you guys this one so that I don't want anybody saying, hey, this doesn't work for me. All right, that works. All right, let's rebuild it. Like usually it's supposed to be just using the cache, but since it knows there's difference, it's not going to collect Flask, installing packages, and done. So Docker remove and Docker stop app container. It first stops the container, and if that was successful, that's what the double and signs do, is that it then just actually removes the container itself, so it doesn't pretty much exist. So yeah, and then we just run our Docker run command, and that generally takes care of everything else. All right, so Docker run app container 6002 to 6002-d. Not sure if this is going to work right out of the box, but let's see, shall we? Yep, internal server. So that was the bug I was telling you guys about. I don't want to spend too long debugging it, but this is a pretty good example for how you can sort of start debugging your stuff. The fact that it happened so quickly is actually kind of good news. Let me check something out in that case. Movie. I said movies over there. Nano app. So before I do that, I'm going to show you how to actually view logs. So that's fairly straightforward. You do Docker logs, and then you have all the ones that are working. We need app_container. Oh, by the way, it names them like weird stuff if you don't name it yourself, like optimistic Babbage. What is Babbage? I have no idea. I'm going to look that up. What is Babbage? Definition of Babbage. He's apparently an English mathematician. Okay, I didn't know math had English in it. What the hell? I know what you guys are thinking. That's not how it works. Anyway, so type error collection object not callable. If you meant to call defined all method of collection objects failing because no such method exists. So I think I made a typo over there. Nano app. Yep, find all. It's actually supposed to be find. I think I'm supposed to send this. Let's see if this works. And I actually did, so I did my collection app.db of movies. Remember how I said before that if we wanted to get information about the participants, we would do print, like if I call this A, like if I define this as A, we do A of participants, right? The exact same thing is happening over here where we're like, oh, my client, select which database it has. Then from the database that we have, we select which movie we need. And then we just do a find command. And yeah. build app. So now, like, interestingly, it got done super fast because it's actually not running installing the requirements again because it's already cached. And then we just stop the application and rerun it. This is where Docker Compose comes up really, really handy because what it generally does is I could define a compose file with all the parameters and configs that I need, so I wouldn't have to like keep rerunning the build stuff, and it would honestly take care of all of it for me. Let's see if it works this time. Movies. Yeah, I think it's gonna end up crashing. See, internal server error. So did not return response. Response must be this. All right, last trying attempt. List. Docker build. Docker stop. So it stops everything. Like even if it does like show the error message, it works on a separate thread. So it's still working in the background. You just messed up like one single thread. Most web development, or at least this stuff, is focused on, wait, fingers crossed. I think it's working, but I have been wrong before. Either that or it's going to time out, which I'm like 90% sure it is going to probably time out. Yeah, it's probably timing out. All right, so generally that's supposed to work. It's a bit of a network hassle that I still haven't figured out or spent the time working on. Internal server error, internal server error. Yeah, internal server error. Files exist, we can see them, but I wasn't able to get, but yeah. And generally this is where I'd start moving over to getting Docker Compose working, but like this is sort of like where it starts becoming a little bit more important to get that. So I'm going to sort of be glossing over that, and this is essentially how you build and develop stuff on Dockers. Actually, what if I just spend like 5 more minutes actually debugging? Do you guys want to see how a continuous integration pipeline works, which essentially whenever you do a git push to your whatever, it automatically checks whether or not stuff is working, or do you want to see me continue working on this and try figuring it out? Votes in the chat. Yeah, connection refused. Did. All right. I'm looking up some of my other projects. Maybe they'll help me figure this one out. It's just it's probably like one very small thing that I'm just forgetting, and that's causing the whole thing to start breaking apart. Just like everything else in life. What if instead of doing 0.0.0.0, I just run it on 127.0.0.0? I build it again. I stop the containers again. And I run it again. All right, this is working. Nope, it's probably the same error, right? Container. Return type must be a string dictionary or that. That's actually a pretty good error. Let's figure this one out. So generally, this is a little bit better for deployment stuff. When I started debugging, host already in use. Docker stop and remove this. So I'm just testing out in Python itself first, just making sure that I know what the bug is before I could properly do it in Dockers. Shouldn't be too much of an issue. Let's just get instant response. And over here, and I hit refresh, internal server error, and then I can sort of see class pymongo cursor.cursor. Like, it'll literally take me like 1 more minute to figure this one out. What if I just do find one? Because it is getting something back. That's what the, yeah, 500. Return type must be a string, and the type is a dictionary. Oh. String, dictionary, or tuple, tuple, tuple? I don't know. It's a weird word. So it is a dictionary. Why is it not working then? Oh, wait. What if I just do this? Oh, I think I know what might be going wrong. Yeah, let's run it now. And it should be working, actually. Type object of type object ID is not JSON serialized. See, so I should spend more than like 5 minutes on this stuff before workshops. So let's just do name x of name. So I'm just defining a dictionary over here. Python app.py, and I'm 90% sure it'll work this time. Boom! So we finally have the name Frozen from our database show up over here. We can also do other comparisons, such as like finding more stuff. So let's say for my backend, I do app, and I want to find out more about like if name. So similar to how we did before, we sort of define like, oh, a name has to be there. So if we give it a name, it finds one whose name is name. So we can sort of like find Narnia or Frozen, for example. And then if we rerun this again with Python, movie/Frozen, yep, we get the same response back that is Frozen. And if we do Narnia, we get Narnia. So it's not actually returning the exact same thing. What it's doing is that it's returning based on what it finds in the database. So if you search for something like 21 Street, because I don't want to add a space, it should raise an error. See, because it can actually find that inside our database, and we can then like come up with some clever words to take care of that stuff. So now that we actually like have this developed and tested out, we can just do, is the container running? No. So we can just literally run, we can just literally like rebuild the container. Like we know this works now, and we can just execute it with Docker run. And maybe like we want to like set it up with some configuration, so we can sort of specify that, hey, this is supposed to be working on a environment such, yeah, this is supposed to be working on an environment that's having that where like we define it as the production environment, so internally it does some other configurations for production, otherwise it does some other configurations for something else and something else and something else, like a lot of different options that we can end up using and working. So let me just share the code that actually works and show you guys that it actually does work. So Narnia, and it's not just like my own dumb luck, it's working because it works. So yeah, next I'm going to show you guys how, like, as you guys probably understood by this point, working with this stuff is kind of like annoying when you're doing it from the command line. So I'm going to be showing you how to install and get started with Portainer. English is not my first language. Please don't make fun of me. And what we essentially do is okay. So Portainer, actually, why don't I just show you guys what it is? I have it installed on my thing right now. 1.11, or is it? Yeah, 1.11. So what Portainer does is essentially a UI, so you can manage your stuff easier, and just makes it easier to like work with these things, you know, with the Docker containers and so on. So it authenticates. It's already signed in and authenticated ourselves. You can see I have like a massive ton of volumes and images, but like 9 containers and stuff. Let me just open the containers, and boom, I can see that all my containers are over here, nicely organized and such. I can, for example, see the MongoDB, the app container that we literally just defined. If you go to the logs right now, this shows up, and we can go to the 192.68 Narnia, and we click on it again, and we just see it, and oh, look, it just added another one like that. Boom. Portainer is super useful, and I really recommend it if you're working with Dockers and stuff. I'm not going to be executing these commands because this is already running on my local instance. Docker volume create Portainer data. This essentially creates, so generally if I were to shut down my MongoDB database right now, it would probably lose all the data that it has, which really sucks, and I kind of don't want that to happen. So what this sort of does is that it creates a volume where you can store information, and then you can restart it to get that information back. Does that make sense, everyone? I'm going to assume that it does. Right. So that's just like a special way to like manage another resource, which is your data itself. After that, you actually have your Portainer command, which is this massive string. Docker run detach from screen, expose port 8000, expose port 9000, set the name to be equal to Portainer. Always restart this, so that if at any point this thing crashes, it'll bring it back up. This can be the same for our Docker container for our app or any other thing. If you think it's something that's supposed to be always up, then it's always supposed to be up. Then you have some the volume stuff that we were just talking about. Map Portainer data to Portainer, blah, blah. And if I were to run this, it'll actually raise an error saying it's already in use, but fairly useful stuff. I'll post this on the group chat as well. Like, you're sort of like, I hope you guys are sort of understanding why I say it's the last thing you'll probably ever install. Because like once you like get familiar enough with this, you won't have to install anything again, because because once you have it installed and set up, it can literally run everything else that you may or may not need. So yeah, sorry that this is sort of like closing in on the end of the workshop. Is there anything you guys want me to sort of like show you guys? Yeah, let me know. Pigming, Rainbow, and Yikes. All right. So this is more or less the end of our workshop. If you guys want more resources and want to learn more how everything works together, I will post a link to one of the tutorials that I found pretty useful. The Docker documentation is also very nice. Yeah, if you just follow this link, it should be pretty easy for you guys to follow and just start working with it. Other than that, if you guys have any questions or concern, I'm going to be here for the next 5 or 10 minutes. Maybe you guys want to learn how to essentially set up some like understand a little bit more about microservices architecture. Microservices, essentially how they work is that you have different services that are able to talk to each other through just individual ports, and they're all talking to each other through these backend Flask apps. Yeah, and that's just how microservices sort of works. It's like I have all of these different containers, and they're all talking to each other through Dockers or some other orchestration tool, and it works pretty nicely that way. Because now each individual system can build and work independently, no matter sort of like however it chooses, and that's super, super useful. Do you guys have any questions? Let me know. I'm going to be here for the next 5 minutes. Hope you guys enjoyed the workshop, and hope you guys had fun at this Learnathon.